So day 10. So this question is called Bulls and Cows, and you're playing the following game with your friend. So you write down a number, and ask your friend to guess what that number is. And I don't think it is mentioned, but your friend at least know how many digits there are. Right. So your friend try to guess that number. Then you have to provide them two hints. First is like you tell them how many digits in the guess match your secret number exactly in both digit and position, right? So you have to tell them how many positions are absolutely correct. We will call that number bulls. I'll explain what that means with an example as well, and how many digits match the secret number but are in the wrong position, right? So how many numbers match but are in the wrong position, we call them cows. And you need to just provide this hint to them based on the solution, right? And then we'll see how to provide the output. So let's look at number 1807 and 7810. So if you look at first index, no, they are not matching. So it is not a bull, right? And then you look at second index, which is 8. So 8 matches at both position and value. So we have one bull. If you look at 0, then it does not match. If you look at 7, it does not match. So we have only one bull. So the first part of the answer will be 1, and then we have to print A, and then we'll have to print B. So like A is used to indicate bulls, and B is used to indicate cows. So basically you have to answer two things, but one is bulls and one is cows. Bulls is easy, which is like you iterate over all the elements and you just see which value matches, right? So that's how you get this. So let's talk about the bulls in this case as well. That 1, 1, 2, 3, first index does not match, 1 and 0. Second index does match, like now I'm referring as 1 based indexing. So 1 and 1 match, so 1 bull. Then 2 and 1 does not match, 3 and 1 does not match, so only 1 bull. Then how do we actually get cows, right? So here we need to use a little bit of observation and try to give some time to understand what is happening. So so what are cows? First of all, it is those digits which match in value but are in the wrong position, right? So suppose somehow I take away all the values which were at right position. So now the number will become 107 and 710, right? So 8 was matching. So now the number becomes 107 and 710. How do we figure out which numbers are same but at different locations? So all the numbers in these two numbers will be in different location. How do we figure out how many of them are same? Is actually simple. We see if any of those numbers here match any of these numbers here, then we remove that. For example, if we just remove 8, then we have 107 and 710. So we check 7 is here, 7 is also here, we remove it. Then 10 and 10, so we remove both of them, right? So 3, because 7 matched, 1 matched and 0 matched, right? So you can look at any way, like you can see first 1 matched, then 0 matched, 7 matched, so that's why it's 3. Now think about this case, 1, 1, 2, 3. So 1 matched, we removed it. Now we have 1, 2, 3 and 0, 1, 1. Now 1 matched, we remove 1. Now we are, so let me write this down so that it's more clear. 1, 1, 2, 3 and 0, 1, 1, 1. So if we look at this 1, which is at second position, right, then it is matching at both location and value, so we remove it. So that's why we have one bull. Now to figure out how many cows are there, we just remove the matching ones. So 1 matched with 1, 1, so we removed it. Now nothing is matching, so one bull and 1 cow. So that is what we need to do. So this is just implementation now. If we are able to come up with this observation, that how to come up with cows after we have looked at bulls, then it's easy. So how will I solve it? Is like I will make a map. I'll make two maps. I'll make two maps each for each of those numbers. First one is the secret which you have, and second one is the guess which your friend made. So I will make both of those maps. But will map store? It will store the count of, right? So listen this carefully. Is that, as I mentioned, that to guess the cows, it was easy. So if you think about when we have removed cows, we have removed bulls, then this will be remaining. What was I doing? I was removing each of them one by one, right? So how many of them will be removed? It will be the minimum count, right? So if there were 2 ones here, then both of them will be removed. But there was only 1, so count here is 1 and count here is 2. So minimum of them will be removed. So if I make a map of these two, like map will look something like this. How many, so this is frequency array, right? And 1 will be 2 times and 0 will be 1 time. So I iterate over all of them, like I iterate over 1, then we see that 1 and 2 is there. I pick out the minimum, so 1, right? I can take out at max 1 1, and then 2 is 1. In this case 2 is not there, so I can't take anything because 0 is minimum. So you can assume that 2 is also here, but it is 0, something like that, right? So that is what I will do. So first I figure out what are cows, what are bulls, and I remove them and I prepare this map. And we can actually do this in one iteration. So let's see how we can do it. So let map for secret will be map s, and let map for guesses will be this map g. Then we need to instantiate everything with 0 so that we don't think about that case where one of them is absent. So digits can only be from 0 to 9. And map of, then we just do map s of I. So because we will be working with strings, so I'll put them as strings. Otherwise, I mean, you can do it both way because these are strings, so ith element will be string. So map of I, map of this character, right? So let's think about it. Oh, so we are initializing, then it's easy. Then we initialize everything to 0, then we will count the frequency later, right? So maps of I plus 1, we are just initializing here, so everything is 0. Done. Now we need to count the frequency for let I is equal to I is less than. Now we don't know what is n, so n is secret dot length. Now we count the occurrences. So that is easy. Map of we will just increase the value, right? Map of s, or then secret of I plus, we are converting them to string, so so secret of I will already be a string because it's a character, so we don't need to convert it to anything because we are converting numbers to string here. I think it might work other way also, but yeah, you can think in your language what do you want to use, number or character. I'll convert it accordingly. So we just add it, and map of g, then guess, right? So now we would have counted everything, right? So think about this, and let me run it for let me think about it. I don't think this is what we wanted to do. So we wanted to do this after we have removed the bulls, right? So that is what we wanted to do. So how can we do it, right? So let's think about that for a moment. And what will be our answer? Will be bulls and cows, right? So now think about this. How will we do it? So only case in which we will not be adding these elements will be the case of bulls, right? So and when will that happen? So let's say const s is equal to secret of I, g is equal to guess. So these are the current characters. If they both are equal, right? That means we have found a case for a bull, right? So I think this will go in else, but let's see. So if they both are equal, then we know bulls has to increase, right? So that's it. But in other case, if it is not a bull, then as I mentioned that we will form this array, these map, and that's when we need to do this. So we can just do s, we can just do I, g, right? So let this sink in. So what we have done here is basically when we iterated, if we see that they both are equal, that means it was a case which we had to remove, and removing that means we don't consider it while counting the frequency map. So that is what I did. So this will act as if like this frequency map was constructed after they have been removed, right? Because we are not considering equal cases. So that's it. And now it is easy, right? So now for all the digits in these map, I just need to figure out which is the minimum value. Then 10 actually, and then cows will be equal to, so how many times I can remove a digit will be the minimum of removing from both of them. So which will be map.min map s converting it to a character, and map g, converting it to a character. That's it. Then now we have to return bulls plus a. So this is how they want the answer, cows plus b. Right, so let's try to submit this and let's see if it is giving the correct answer for these two cases. Let me write the second one also, because that is where we have duplicate case. So let's run it. So it is giving a correct answer for these cases. Let me just submit it. So this is accepted. So what is the solution? Let me just reiterate. So how do we find bulls is very easy. We iterate over each index, and if we see if the value is same, then we know that it's a bull. That is okay. But how do we figure out cows is like we remove all those elements, and whatever remains, right, we know the position can never match, so we only have to match the value. So suppose there is a number 1 here, and we have to check how many times this matches with 1 in second array, because position now can't match. So we think that 1, let's remove that 1. So if there was another one, we remove that one as well. So how many ones can you remove? If you have x ones here and y ones here, then you can remove minimum of those, right? So if you can remove x from here, then you can remove x from here as well if x is lesser. So something like that. So that's why we are preparing that frequency map, and we are taking minimum of both those values, right? So that is how we were able to figure out how many cows are there. So something like that. So hope this was clear, and thank you for watching. Bye.